during this presentation, there's not going to be a single slide. I'm just going to be doing live coding for a whole hour. So be very careful, because there's going to be a lot of code. I hope you can see it right here. I'm not going to be showing you any content, any pictures, nothing, just live coding for 60 minutes. So let's start. And I have a little bit of a plan here. So we're just going to follow along. All right, so during this presentation, I'm going to show you how RxJava works, but not the basic stuff, the things that you can find in any documentation. What I'm going to do, I'm just going to go through a couple of examples and show you how you can actually use RxJava in your current project without rebuilding everything from scratch. So I'm not going to be showing you like different operators. I'm not going to be showing you a marble diagram. So pretty much what you can find in any single presentation, just live coding with very interesting examples. All right then, so let's start with a simple test. So what I'm going to be doing is I'm going to be writing a small self-sufficient samples. Let's call it like this one. And these are not going to be real tests, just more like short code snippets. I'm going to publish all of them on GitHub after the presentation. And I'm just going to be going through a different code samples. So the thing is that if you have any questions, if you want to clarify something, if you want to go with some very specific use case, then just pop a question right now when you have it, and we're going to be coding along and trying to figure out how we can help it. All right, everyone's ready? Great. So let's go. I haven't mentioned it, so my name's Thomas, and you can reach me on Twitter. And I have a website, and yeah, that's it. OK, so let's start from the very beginning. How many of you know what Completable Future is from Java 8? OK, not all of you, surprisingly. So, and do you know what a future is, Java util concurrent future? OK, so let's make a very, very short introduction, because it's actually useful from the RxJava perspective. I assume you don't know RxJava as well, because it's kind of a higher level thingy. So some of you may, but not all of you. OK, so Completable Future is basically like something like a container for something that's going to be visible or available in the future. And by something, I mean some sort of asynchronous computation that happens in the background. So I can say, for example, Completable Future, well, already completed with value 42. Do all of you see the screen? It's really essential, so you must see the screen correctly. If the font is not big enough, then I'll just increase it, which is actually beneficial because the code samples have to be then shorter. OK, so here's a Completable Future. It's actually from Java util concurrent package, so it's not something you don't normally find in your Java code. It comes from Java 8, and the basic idea is that when you start an asynchronous task that happens in the background in a different thread pool, maybe it's a non-blocking operation, whatever, you get a completable future in return. It's part of the JDK right now. And what you can do, this one is a bit unusual because it's already completed. So it's kind of a future that already has a value. But normally, your completable future you just get a completable future, which is a non-blocking thing. And then you get a response back, and then you get a callback after like several milliseconds or maybe an hour or something. So here you have it. Here you have a string. But what's really important about Completable Future is that you can apply transformations on the contents of the future without actually waiting for the actual result. So for example, I can say string, which is my future, or let's just call it a future, then apply. And here I provide a function. I hope you're all aware with Lambda expressions and with Java 8. So by saying then apply, I can apply a transformation on the contents of the completable future without actually blocking on that future. So what happens is I have a string because my completable future holds a strongly typed value of string, which basically means I will get a string sometime in the future. There is some database query or something that's going to finish in the future. So I have a string, and let's call it result. And now I can apply some sort of transformation on top of that value. For example, result length, which returns an integer. And now I have a question for you. What's going to be the type of this expression if I extract it to a variable? Exactly. It's actually completable future, I think, or maybe completion stage. We're going to see it in a second. Yeah, it's completable future. But stage is also a good example, a good response. So here we have it. But for the rest of you, here's what happens. So when I have a completable future, which represents a value, a single value in the future, then I apply a transformation on that single value that is not yet available. It will be available in a millisecond or maybe a couple of hours. When I'm applying this transformation, I'm not actually waiting for that result. The only thing I'm doing is that I'm remembering the transformation, I'm remembering the actual function, and when the value appears sometime in the future, this transformation will be applied before I get the result back. And that's why the result I get is a future of integer. So I have a future of string, so some string that will be in the future, and when the string appears, I will apply a transformation, and then I will get a future of integer. Do you get it, like most of you? Okay, fantastic. So this is actually a very good introduction to RxJava. So here we have this then apply. And the reason why completable future was so fundamental in Java 8 is that it's non-blocking. So I can actually compose several completable futures with each other. I can have a very concurrent applications with not much of a syntactical sugar. And I can actually chain these then applies. So I can say, for example, then apply x times 2.0. Oh, sorry, that's what I wanted to write. And now question to you, what's going to be the type of this expression? Oh, louder? No, it's not going to be double. Of course, it's going to be a completable future of double. Di, let's call it di. Because this is a completable future of string. After applying a first transformation, I get a completable future of integer, because I don't wait for the value. So I cannot get an integer, because that would require me to block on the future. And the purpose of completable future is to avoid blocking under every circumstance. And after, when I have a completable future of integer, I can apply a second transformation on that integer, which is doubling or multiplying by 2.0, a double of 2.0. And in this case, I get a completable future of double, which is really cool. And the basic idea of completable future is that you never block, or that you avoid blocking under all circumstances, so that you just keep applying. You can compose different completable futures with each other, so you can take two futures and combine their results together without actually blocking, which makes it really efficient from the CPU and memory perspective. All right, clear so far? Just nod your head if it's clear. Okay. So now let's go into RxJava. RxJava is like a completable future, but with multiple values. So rather than having a single value that is like bound, like placed in a completable future, which will be available in the future, in RxJava you actually have multiple values that will appear in the future. So in some sense you have a stream of data, and this stream of data will actually just keep coming to you in the future. So for example, this can be an event every second, or this can be an event after several hours, whatever. But the basic difference is that when you have a completable future, it can complete with two different results, either a single value or an exception. With completable future, with RxJava and with observables, because this is the basic type in RxJava, with observables, should actually be imported. With observables, you can actually have multiple results. So you have a stream, a sequence of results that are appearing over time, and you don't really control how fast or how slow they appear. And optionally, this stream can be terminated gracefully with just a normal completion, so that the stream of data signals that there will be no more values. Or there can be an exceptional completion. So there can be from 0 to infinite number of events, optionally completed with a normal completion or an exception. Okay, so let's just make a really, really simple example. 1, 2, 3. This is an observable. So this is a stream of data. Let's call it numbers. This is a stream of data that actually produces 3 events, 1, 2, and 3. So if it produced only one event, like 42, it would be really, really similar to a completable future that we already saw above. But in this case, we are producing 3 numbers, 1, 2, and 3. And what's going to happen is that when you have a stream of data, you actually have to fetch this data somehow. You actually have to get this data somehow. And it would be nice to get it in a non-blocking fashion. So The simplest approach is to just subscribe to such a stream of data. So an observable, or in RxJava 2 that was just released a couple of weeks ago, something which is called Flowable. In observable and Flowable, they are basically a producer. So they produce data in some points in time. On the other hand, when you want to consume the data, the consumers, the receivers, are called the subscribers, can be plugged in with a subscribe method. So here's the idea. You have your observable. I'm just going to make it up higher for you. This is our observable, and when you subscribe to it, your subscriber, so whatever expression you put here, this can be something like, this is my number, and I'm going to print it. All right, so you pass a lambda expression, in a sense, you pass a callback, that just feeds you the data. And this typically, it's not by default, but typically it's going to be executed asynchronously. So you're going to get callbacks from some different thread. If you have any questions, then just go ahead, then we'll follow along. Okay, is it clear so far? Let's just run it and see how it works. All right, I got 1, 2, and 3. Just to prove that it actually works, let's put something here like got. Right, let's run it again. So this is a very, very simple stream that just throws 3 numbers. In general, you would get more complex streams that are representing data coming from the network, from the file system, from JMS, whatever. This is just like to familiarize you with the syntax. All right, so let's actually jump into our real application. So once again, any questions, just follow along. Yes?
Sorry?
What kind? You asked about dispatcher. What kind of
repeat
dispatcher
your question.
do you mean?
On what thread does this code, will this code run?
Okay, so by default, RxJava doesn't involve any threading at all. So everything here runs in the main thread, in the client thread. I can actually show it to you right now. So I'm going to make a very simple method that prints anything, which is going to be useful for the rest of this talk. All right, so I'm just going to print it whatever I placed here. So the question is which thread. The question is which thread executes all of this. So by default, there is no threading involved, which means RxJava by default is really, really fast because there is no jumping between threads. So if I run it right now, and if I just use the log method recently introduced, print, sorry, thank you. You're going to see that everything runs in main thread, okay? Main, 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 and so on. But this is a default, and it's not used very often. And we'll see in like 2 minutes how you can apply threading into your RxJava application and how do you apply concurrency in a very declarative manner. All right? Great. Okay, so let's jump into something actually useful. So I have a few very simple classes that we're going to use that are going to pretend we're actually doing some real work here. So I have a weather client that pretends to be loading weather from some API, whatever. Doesn't really matter. And this one is blocking. So I actually placed a sleep here of 900 milliseconds, which will be, I think I'm actually using 2 microphones right now. No. Which is going to be quite useful from the perspective of various operators we're going to see in a second. So how do you turn a normal blocking API into an RxJava API? It's actually really simple. I'm just going to copy the declaration. And instead of returning weather, which is like a blocking response, normally in Java code you would return completable future of weather to signal that the thing is asynchronous. Because what I'm going to do right now is that rather than having a blocking call that blocks when I'm fetching the weather, I would like to make it asynchronous. So I want to say that my weather will actually come from an observable. And there's nothing wrong with having an observable that just emits one value, like a completable future. It's just a special case, and there's nothing wrong with that. And what I'm going to do is that I'm going to wrap the actual logic in a callable. You see, this is a callable. Let's make it bigger. I think I have way too many. Yeah, here. So I'm going to wrap it in a callable, and I'm just going to call the original method here. Right, this is a very very, very popular pattern. You just wrap an original code in an observable. Okay, I think I can actually make it simpler. Right, so what happened here is that I took an ordinary blocking code, I wrapped it in a callable, so in a way I wrapped it in something that I can run later, and then I'm turning it into an observable. So what's going to happen is that every single time someone calls RxFetch, I'm going to get an observable of weather. And in this case, I'm not going to get a stream of data. I'm just going to get one single value that was returned from this method. Let's see it in practice, and then we're going to learn a little bit more. All right, so I have new, let's put it here, new weather client. Just assign it here. Can't. Weather client, so much typing. All right, and I'm going to call weather client. And let's first call it with the normal method, the one that was blocking. If I call it with some city, whatever, I just get a weather back. That's like a fairly simple thing. And if I run it like now, you're actually going to see some logs coming from it. So loading for Minsk, and I actually got the weather back. I haven't printed. All right, and here it is. So this is like a normal Java code. There's absolutely nothing special here. And you see I got a response back. Minsk equals sunny, because that's the string of weather. Okay, but what happens if I replace the blocking code? Oh, you know what? Let's just keep it. I'm working in an append-only fashion, which means I'm trying not to delete any code because I want to put it later for you on GitHub. So please remind me if I'm deleting something. So I'm just going to make a second sample. So what happens here is that rather than having a blocking call, I'm going to run RxFetch, which is the second method that we just created. And just for the reference, let's look at it again. Rather than calling fetch directly, I'm wrapping it in a callable, and then I'm returning an observable. So what's going to happen when I subscribe to this observable? Well, nothing happened yet. So creating an observable doesn't execute any logic yet. It's lazy, which means that you can create an observable which is called like query the database or download whole internet, and nothing's going to happen as long as you don't actually subscribe to it, which is a very interesting feature of RxJava. So what happens here if I subscribe at the moment? And here, let's just go, okay, I have weather, and then I can print the weather. So just like before, but just to make it clearer, I can say this print, right? This was our callback method. Okay, let's comment this one out. So what's going to happen? And there's still no threading involved. So there's still everything happens in the main thread, but at least we get a result back. If I don't have a subscribe part, I would actually get no result at all, because as long as I don't subscribe to an observable, it's still lazy. So an observable is basically just like a data structure that's used that can represent some computation. But the big difference between Completable Future and an observable, except the fact that observable can emit multiple values, is that an observable is lazy. So as long as you don't subscribe, nothing happens. All right, but what's the actual reason for it? Because it made our code much, much harder to read. Rather than just calling fetch directly, we're just wrapping it in some callable, then wrapping it in an observable. What's the point? We're just starting. So let's say that you want to fetch this weather, and what you actually want to do is you want to make sure that you're not waiting too much for it. So you want to apply a timeout. So timeouts are actually a bit hard in Java because you have to like submit something into a separate thread pool, then just wait for it or whatever. In RxJava, this is really, really simple. So remember we were subscribing. Let's start from this. All right, here's the code. And now I want to make sure that I would get a result within 1 second. So I don't want to wait more than 1 second for weather. If I wait more, then I should get an exception or something. So what happens in RxJava is that I simply apply timeout of 1 second. And that's about it. Go ahead. All right, so I just inject a single operator, and you can put as many operators here as you want. And I'm basically saying, OK, so here's my observable. And if it doesn't emit any value within 1 second, just complete with an exception. So if you remember, our original fetch method actually has a sleep of 900 milliseconds here. which means it's less than a second, so it should work. So let's run it. And in this case, we will get a result. So, but if I decrease the timeout into something like 800 milliseconds, all right, I would actually get an exception. And this is that simple. You see there was a timeout exception happening just here. So that's a very, very simple use case of how you can apply timeouts into your code without too much trouble. But let's make it a little bit more interesting. So let's imagine you have a cache server. A cache server that does caching, whatever. Let's call it cache1 equals new cache server. Okay, and this cache server contains some data and it's replicated, which means we can actually have two cache servers, for example, in two availability zones. Let's call it one EU and let's call the second one US, all right? And we don't know which one is closer because we don't want to know it. We just know that one of them is closer to us, so it's going to return the result faster, and the second one is further away, so it's going to return the same result, but it's going to be slower. So we have these two cache servers, and they actually have a very simple method called find by key, 42, whatever. So this cache server contains whatever. It can contain cache person data, or we don't really care. The thing is that what we want to do here is that we want to query both of these servers at the same time, and we don't really care which one is faster. What we really care is that we want to get the result from the faster one and discard the result for the second one. All right, is it clear? It's supposed to work? Okay. So doing it in Java is really, really, really painful because you're going to get like two futures, or you need some thread pools or whatever, because obviously we want to contact both servers at the same time. So what happens here is, first of all, I'm going to make it more Rx friendly. So here I'm pretending I'm downloading some data from memcached. I can put some sleep here as well. Sleep duration of millis, let's say 100. Doesn't really matter, but let's just make it more entertaining. And I'm going to create a second method. And this time it's going to return an observable, which already means we're somehow going to make it asynchronous. So this time let's call it RxFindById. And the exact same pattern. So observable from callable, find by key. This becomes a little bit boring, but it's really, really fast. All right, so we have a second version of the cache server. This time it uses RxJava. So what happens here is that I can now say RxFindById, which returns an observable of string, and let's call it EU result. And I'm going to do the same thing with US. Okay, so now I have two observables, and there was no communication with memcached or whatever I'm pretending I'm doing. So this method wasn't yet executed because it's lazy. I just have two observables, which are placeholders. And what I can do right now, you have a question, yeah? Okay, yeah. Copy and paste error. Fair enough. So here we have two results, and what happens right now is I can do EU result merge with US result. And the reason this method is called so weirdly, because what I'm actually doing is that I have two observables, and we're going to see it in a second what's the type of it. So this is, let's call it all results. So here's the idea. I have two streams of data. These streams return just one value, which is basically just like a single string. We'll see more complex streams in a second. These two strings are returning, these two observables are returning strings. So what happens, I have two streams of data, and I'm combining them together, or I'm merging them together, which means that no matter which of these streams emits an event, I'm going to get it in my final stream. So this stream, the all results stream, will actually yield two results, two items, two strings, or to be precise. One string from the EU server and one string from the US server. Is that clear? Okay, so for the all results, I can actually say all results first, which means I'm only interested about the first event that will appear in this stream, and I would like to discard the second event because I don't care. I know that both of these events are going to be the same because the cache servers are replicated. I'm just interested about the first one. And here I can just say subscribe, and it's going to give me the result. as simple as that. The thing is that we haven't yet introduced any concurrency. So coming back to your question, everything happens in the main thread. So it's not actually concurrent yet. Everything happens in the client thread, which means it's still not parallel in any sense. But it turns out having an observable and making it concurrent is actually really, really simple. So if we look at it first, we're going to see now there's no concurrency. So you'll see that everything happens in the main thread and everything is sequential, which is not precisely what we are aiming at. The thing is that I can actually now go to this implementation, which is observable from callable. And remember first, previously we used the timeout operator, which maybe is a good idea anyway. So let's put it here. Or let's make it, I don't know, 50 milliseconds, which is actually less than 100 milliseconds here, so it's going to fail. So I'm going to make 10 milliseconds here. So I'm willing to wait at most 50 milliseconds for the result. But here's another thing. I would like to run this code on a different thread pool. So what happens is this tiny little line basically says, here's my observable, and by default, this observable is executed in a client thread. So if I have some logic here, and if I subscribe to this observable, this logic will be executed in the client thread. So the client thread, the one that calls subscribe, will actually block. This is the default behavior, but it's not really something that you would expect. That's why with this tiny little line, subscribe on schedulers.io, and we're going to explain it in a second, you're basically saying, OK, my logic from the stream is supposed to be executed in a different thread pool. And that's it. And you specify the thread pool basically here. I/O is a built-in thread pool that just has an infinite unbounded number of threads. There's also a computation thread pool, which has as many threads as cores. And that's pretty much it. So that's the only thing you need when you want to make your code concurrent. And if you have multiple streams, like here, then you're going to get one stream executed on one thread, the second stream executed on another thread, and you get true parallelism. I hope it's going to be visible. Oh, so now we didn't get any result because suddenly our observable is asynchronous. So just to make it really simple, I'm going to put a very, very simple sleep here. And there are better ways to do this, but we're going to see them in a couple of minutes. Duration of seconds, 1, all right? I need to sleep because now the computation happens in the background, so I don't get any results. So look what happens. We actually get true concurrency. Do you see the terminal, by the way? Here you should see it. We now get true concurrency. We see that there are two threads, IO scheduler 2 and IO scheduler 3. They both contact memcached, but we get the result from just the faster one. And the faster one happens to be the one that started with thread 2. Of course, there is no guarantee that that's what's going to happen. The bottom line is, because we use the merge with operator, which is here, it took two streams, which were completely asynchronous. It collected events from both of these streams into a single one. So in a sense, it just like grabbed all of them and squished them into a single stream. And then because we used the first operator, we actually just got the first result from the faster cache server or from the faster stream. Of course, if there wasn't first operator here, we would get actually two events. All right, from both of these streams. Yes?
Why is the print operation executed on the same I/O thread?
Very good question. So once again, this is default because we want to avoid the overhead of jumping between threads. But that's a very good question. So this is the computation. This is the thing that produces the events. And this is the subscriber. This is the thing that actually consumes the events. So I don't think we're going to have time to dive very deeply into this. But the idea is that if you once say that you're subscribing on something, it means that everything is going to happen on this thread pool. But this is not necessarily the case, and there are actually just two operators in RxJava that control threads. The first one is called subscribe on, but if you really want to, run your subscribers or part of your pipeline in a different thread pool, that's just damn simple. You just say observe on, and you pass in a different thread pool. So what observe on does is that it just jumps into a different thread pool. So if you have like a very long pipeline, you can actually have map, you can actually have filter, right? So you can have many operators in chain, like here. The thing is that if you run, actually didn't want to comment this one out. The thing is that if you put observe on in some place in your pipeline, it means that events will start processing in a different thread pool. So they will just jump from one thread pool to another. You get it? Okay. So just to prove that it actually works, we're going to see the output right now. Okay, so here we have two events executed on the I/O scheduler from threads 2 and 3. And this happened in the scheduler that we passed to subscribe on, so to this one. And all the computation by default will run in this particular scheduler. However, because we used an observe on operator later on, which just causes us to move to a different thread pool, the subscriber, so the one that receives the events, actually executes in a different thread pool. This brings a whole lot of problems because suddenly you have queues between threads, but it's like a very, very simple mechanism. You're saying, this is my thread pool, and please start processing events on this pool. Does this answer your question? OK, great. So one more thing. What we have more is that, OK. So now let's go into something a little bit more interesting. All the streams we had so far had just one event, which is not really interesting. Let's create a special type of observable called interval, which is going to emit an event every second. And this event is just going to be a number 0, 1, 2, and so on and so forth. So let's subscribe to it. And I'm going to use a special operator called toBlocking, which basically allows me to, which basically causes the subscribe to block, because by default subscribe is asynchronous, which means this test is going to complete immediately, and I'm not going to see any results. So let's just make it blocking, and let's run it, or just to prove you that it will actually finish immediately. Okay, nothing happened. But if I put toBlocking, the subscribe method suddenly becomes blocking, which allows me to observe some results. You see I get 0, 1, 2, 3, and so on, and it happens in the main thread. If I don't want to run this test infinitely, I can actually say take 10, for example, or take 5. And it will just give me the first 5 events, and then the test will terminate. All right, so I get 0, 1, 2, 3, 4, and the test terminated. All right, so interval is actually very, very useful operator when you want to run some code periodically. So here's what's going to happen. Can you imagine a situation where you have a folder on your file system and you want to poll for changes, you want to poll for new files in this folder, which is actually a fairly common thing you do. You have an FTP folder or a file system folder, and you want to discover new files in that folder. So what's going to happen is that first I'm going to create a method that returns a list of files in a directory. Let's call it children of file directory. All right, so I'm going to create a method that returns the list of all files within a directory. So if I remember the API correctly, it's list files. Yes, it's list files, and then I'm going to create a list out of it. I have a very special question for you. I think you can notice that dir.listFiles is actually yellow or brown or whatever. Which signals that there is some warning from IntelliJ. Can you tell what the warning is? It's unrelated to RxJava, yeah? Nope. No. This is an array. All right, and the warning is here, which I actually just revealed, sorry. The thing is that list files, which is different from every single method in the Java I/O package, if there is an exception, or sorry, if there is any error, for example, the directory doesn't exist or it's inaccessible, returns null rather than throwing an exception. So this is probably the only one of the very few examples in the Java API that actually return a null rather than ordinary exception. That's why it tells me that this is null. Yes? Yes, that's correct. I think they return Boolean, right? Yes. So sometimes you get I/O exception, sometimes you get Boolean, sometimes you get null. It's like, yeah. But I'm going to pretend that the null is not going to happen here. The thing is that what I want to return is basically a files I would like to extract a file name. So let's just go with file get name and return a list. All right, so what happens here is that I have a very, very simple method that returns a list of files in a given directory. Let's make sure it works. I think I have to actually return it. So, children of, and let's just have a directory called it's just a directory I happen to have on my file system. I hope I have it. All right, and let's just print the list of the contents of this directory. All right, we're going to get null pointer exception if the file does not exist, but it exists, and it returned me an empty list. So let's go to that directory. It actually makes sense, all of this, what I'm doing. Temp, and what was it, jetconf. All right, let's create a file called foo. Run the program again, and it should return a list with one file. Okay, that's fairly straightforward. It's just like the beginning. So what I want to do right now is that I want to poll the file system for changes. So let's say every second, I want to go to a file system and list the contents of that directory. So here we have it. So what I'm going to do is that I will start from an interval that runs, let's say, every 100 milliseconds, so 10 times per second. And I would like to look what are the current contents of my file system. So what's going to happen is that events here are basically just integers, but I'm not interested about these integers. These are values like 0, 1, 2, 3, and so on. I'm not really interested by them. What I'm interested in is the contents of this particular file. All right, so what's going to happen now, and I'm going to just pass to blocking again to make it easier to test. All right, so what's going to happen right now is that I will get a list of files in this directory 10 times per second. I think it's actually a little bit too fast. Yeah, but you get the idea. 10 times per second, I get a list of files. And what's interesting is that if I change the contents of this directory, so if I create a new file, let's call it bar, I will actually get a list of 2 elements. But that's not the point. What I really want to have is I would like to get an event every single time a new file appears. But that's a good start. So what I'm going to do right now, currently, if you look very carefully, the event is actually a list, because for each integer, for each interval event, I'm replacing it with a list. So I have an observable, and this observable, just to prove you that it works this way, let's call it files. This observable emits events of type list of strings, which is a bit unusual. The reason behind it is that when I'm doing a map transformation, I'm actually replacing a single integer with a list of files from a directory. Is that clear? Okay. But what I really want to have is an observable that has an event per each file. So in a sense, I want to split this list into as many events, as many files there were in a list. So what I can do is that rather than using a map, there are many ways of doing it. Do you know stream API in Java 8? There's actually a way of, like, when you have a stream of integers, and for each integer you get a list, and now you want to get a stream of, not of lists, but you want to get a stream of items from that list. I don't think it was clear, but maybe you got it. Flat map, yeah. So I don't think everyone actually understood what I was saying, so let's just reiterate it. So a flat map is a way of replacing one event with a sequence of events or multiple events. It's typically used to make code more concurrent in RxJava because you can, having a stream, you can actually have multiple parallel streams running along each other, but it also allows us to flatten the list, so to make the list a little bit more like sequential. So flat map would work, however, it requires us to return an observable. So children of would have to be an observable rather than a list. So there are multiple ways of doing this. I can, for example, say observable from list, like this, and now it compiles. What I'm actually going to do is that I will refactor children of so that it returns an observable, which is actually a good idea anyway, because in this case, let's just create a second method, you know. I promised you not to modify any code, so I'm going to work in the append-only mode. Rx children of. So rather than creating a list, and you're going to notice that the code actually becomes simpler, because I can do an observable from, and it can take an array. So here I already have an observable, and I don't have to play with all these stream, collect, and so on, because streams are lazy by default. I'm talking about observables. I don't need to create a stream, and I don't have to collect it. I can just say from, and then map. It's the same map as here. I can actually copy-paste the code. And that's it. You see, they are doing the same thing. However, with observables, I don't have to explicitly create a stream, which is this Java utils stream, I believe. And then I have to do collect. The only reason we have streams and collectors in Java 8 is because collections in Java are eager, which means if I would simply run stream and collect, assuming this actually compiles, and if I had multiple transformations like map, 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 and so on, I would create multiple collections along the way, which would be really wasteful. That's why they invented streams and collectors. In RxJava, I don't have to do this because streams are lazy by default. So there's not going to be any transformation happening at the moment as long as I don't subscribe. So this is more, and this is much more like straightforward, and the API is also much simpler. So let's just return it, just to make it even simpler. I'll inline it. All right, so as you can see, these two methods are actually doing the same thing, but there's less ceremony in the API. Okay, let's go back to our example. So we can do observable from children, blah, 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 but what I'm actually going to do is that I will say Rx children of, and Rx children of actually returns me an observable, which should work. All right, so it doesn't compile for some reason. Let's just write it again, hoping it will next time. Okay, I think I had a brace missing. Okay, so let's go for to blocking and subscribe again. So just to remind you, the whole reason we were doing all of this was to have a stream of files rather than stream of lists of files. So rather than having let's just have it every 1,000 milliseconds, so every second, rather than having an event representing all files in a directory every second, I would like to have an event representing every single file in a directory every second. So once again, running the old version, which was here. Oh, and I actually scrapped it. No, here it is. So the new version is here. And this time, I'm going to get an event per each file in a directory. So I get bar foo, bar foo, bar foo. All right. And if I create a second or a third file called buzz, let's say, I will get 3 events every second. You see? Buzz, blah, blah, blah. So every second, I get 3 events as opposed to just having a list. So once again, if this just was a map, let's keep the old code. If this just was a map, I would get a list of files. Now I get event for each file. So what was the reason of doing all of this? Well, at this point, I can simply say distinct. I'm just adding a distinct operator. And the reason why this works, or the reason how the way how it works is as follows. Every single time an event appears, the distinct operators has some sort of internal cache that makes sure that this event didn't appear before. If it didn't, then the event is passed further. If it did, it's just discarded. So let's run it again. And I have 3 events, bar, buzz, and foo. Someone's going to ask about memory leak. I'm prepared for that. So I have 3 events. And if I create a third one, let's call it, I don't know, jet. So I'm just creating files on the file system. Creating it, and within a second, I get an event jet. But because I use the distinct operator, the distinct operator allows, or actually discards, the subsequent appearings of the jet file. So this works, and this works, but it's not like the best way of doing it, because the distinct operator has to keep a list of all files that appeared in the past. And this can be a problem. It can actually be a memory leak. So in RxJava 2, you actually get an overloaded version of distinct that can take an arbitrary collection. So it can evict items, for example, after 10 seconds or something. So you're avoiding this problem. Here you just have to be careful with that. So everyone understands what distinct is? Just nod your head. All right. In a second, we'll see a little bit more involved example of how how this can work. Or you know what? Let's just do it immediately. So how many of you know Camel, the Apache Camel framework? Okay, so Camel is like an integration framework, and what it basically does is that it allows you to connect to various systems like JMS, email, file system, WebSphere MQ, Kafka, whatever you want. So let's have a very, very short introduction into Camel. Camel has a little bit verbose API with callbacks, but it actually has an official wrapper. So I'm going to start with new Camel context, which is like a factory for pretty much everything related to Camel. And Camel now allows me to connect to any system I want. So my system is going to be a file system, reactive Camel in the beginning. And in reactive Camel, which has a native support for RxJava, actually there are many, many libraries that have built-in support for RxJava, and RxJava is also very, very popular in Android community, because on Android you have clicks, taps, swipes, and all of this, and this is basically an event-driven environment, so RxJava works really well. So what happens is I'm going to put file/home. Basically, I'm connecting into a system, and this system is gonna be my hard drive. So what was it? Jet, I think, or jetconf. Let's get rid of everything we have in here so far. It's empty. Yes, it's empty. So I'm connecting into my file system, and I have an observable. And what I'm gonna do is that I'm simply gonna subscribe. I'm not sure if it's blocking or not. Let's just run it and see whether it's gonna work. Oh, it has to be to blocking because otherwise it terminates immediately. That's okay. Okay, running it. And what happens is in Camel, this is basically a description, an endpoint to a system I want to connect to. And this endpoint is just a file system. So what's going to happen, I'm going to create a file here. And you see that I'm actually running the correct code. Yes. So I actually got a file happening. Let's call it bar. And I get a file appearing. So this is like the way Camel actually shows me. Camel allows me to integrate with something. But let's run, because file system is kind of silly, right? I just used it because it's simple to implement. Let's connect to JMS. How many of you are familiar with JMS, ActiveMQ or something? So JMS is basically a message broker. It allows you to exchange messages between systems. So I'm going to reuse this part of the code because it's going to be the same. And I promise you, this is the shortest way of integrating with JMS you will ever encounter with just using Camel. No Spring, no enterprise servers, whatever. So I'm just creating Camel. And, well, Camel is like 2 dependencies. I'm not really not such a big fan of Camel, but it just works really well during this presentation. So this is all I needed in terms of dependencies. So what's going to happen here? I hear people talking, either you are bored or you have a question. If you are bored, just come up with some questions so that I don't feel sad. So I'm going to connect to ActiveMQ. And in ActiveMQ, there are 2 flavors. There are queues and there are topics. I would like to connect to a queue. And let's call it a jetconf queue. And the rest of the code is actually the same. So there's to blocking and there's subscribe. However, in this case, I'm only interested about the body of the message, which is basically going to be whatever I placed in a message. So come on, Apache Camel message, and I'm interested in body. So I don't have ActiveMQ running at the moment, so it's going to fail, and we're going to see messages that it cannot connect to a broker. And by default, this broker is supposed to run on localhost. Am I running the correct code? Yeah, you see fail to connect to localhost something. All right, so let's just stop it and let's run ActiveMQ right now. I think I have it here. Okay. I'm in the ActiveMQ folder and ActiveMQ console. All right, I'm starting ActiveMQ. Doesn't really matter what's happening. The only thing that you should be interested in is that the ActiveMQ broker is running. So now I'm going to look at the list of queues, and it should be, the list of queues is empty. Let's make it bigger for you. All right, I don't have any queues yet in my system. So now when I run the application, let's just run it again. This time I'm not going to see any warnings. I see that it's successfully connected to ActiveMQ, which is great. And let's go back to the queue, and we see that it actually created a jetconf queue, which has a one consumer. This one consumer is my Camel and my RxJava integration. And nothing happens on the terminal because there are no messages. So now I'm going to make my window a little bit smaller because two things are going to be happening at the same time. Oopsie. Okay. So here's my queue, and this manager actually allows me to send messages. So let's send a message straight to my ActiveMQ queue. And this allows me to send an arbitrary message. So let's say, hello, Minsk. Almost. All right, so this is my message. I haven't sent it yet, but what I want you to focus on is the actual terminal that you see on the bottom. So the moment I send a message to this broker, right now, I actually got this message here. So this is probably the simplest way of integrating various systems. And what's really cool about ActiveMQ is that, about Camel, sorry, is that rather than file system, you can, rather than ActiveMQ, you can put file, you can put Kafka, you can put, I don't know, POP3 or IMAP or whatever. And all of them should work once you have a correct dependency and you get a consistent RxJava API. So no matter what kind of system do you integrate with, you always get a consistent API, which is basically a stream. Okay, any questions to this one? All right. Do we have anything left? I think what I'm going to show you is the window and buffer operator, which are really cool as well. So imagine you have a stream of data. And I'm actually going to make it a little bit faster, so 17 milliseconds. So I have a stream of data that emits an event every 17 milliseconds, just an arbitrary number. And let's say I actually want to process these values in batches. So rather than processing them one after another, I would like to batch them in some way. So one way of batching the events is by the size. So rather than consuming the events one after another, I would like to batch them in lists of 10. So what happens here? It's best explained with just running the code, so let's do it straight away. You see that rather than consuming the events, I think it's a little bit too fast, so let's just stop it and make it slower. Rather than 17 milliseconds, let's have like, I don't know, 150. So I'm now producing events every 150 milliseconds. If I forget about the buffer operator, I would get an event every 150 milliseconds, which is fairly fast. Actually, RxJava can easily process hundreds of thousands of messages because it's just an abstraction layer. There's no processing happening underneath. So don't be afraid about the performance. Of course, there is a performance overhead, but it's not big. And the guys from Netflix, because that's the company that wrote it first, actually optimized it really, really well. Just to give you a hint how well it is optimized, at some point they are extending atomic integer rather than using it because they wanted to avoid one extra memory allocation. I don't know if you ever like extended the Java util concurrent atomic integer class like as an extends clause. Okay, but coming back to our example, so in this case I uncommented the buffer operator because what I want to do is rather than consuming the events one after another, I would like to wait until 10 events appear and then I would like to process all of them in a single batch. So this was the previous output. We got an event every 150 milliseconds. If I run it again, I have to wait 1.5 seconds because that's how much I have to. That's how much time it takes to consume 10 events, and I get batches of 10 events every 1.5 seconds. Is that understandable? Okay. The one more thing with buffer operator is that this is a very simple variant. It actually has a lot of overloaded versions. One of the most interesting ones is that rather than using a value, so rather than saying I want to batch events by 10, I would like to batch events every second. So every second I would like to get a new batch of events, no matter how many of them appeared. So this time we're going to get events precisely every second, but the number of events can actually vary. because we don't know how many events actually step there. Okay, I think we have a few more minutes, 3 more minutes. So I'm going to show you a wonderful testing support in RxJava, because RxJava is all about testing, actually. Yes? I think so. There's actually an overloaded version for that. So the question was, can you combine both by time and by number composition? And there's a version, there should be a version here somewhere. Boundary, I think there was, maybe I'm using it. Oh, here it is. Time span unit, count, and scheduler. Scheduler is something we're going to learn in a second. All right? Okay, so now I'm going to show you a testing support example, which is really, really cool. So imagine you have a SOAP service that returns, oh, let's say, big decimal. And I'm going to call it very slow SOAP service. That just returns me a value of, let's say, 10, or 1, or 10 it is. But it's really, really slow. So what I'm going to do is that I'm going to delay it by, I don't know, 1 minute. All right, so what this code does, works. What this code does is that that's why it's yellow. What this code does is that it creates an observable that emits a single value of 10, but after a minute. So I can, like, having a stream of data, I can actually like shift all the events by a given amount of time. But this is just for simulation. So what's going to happen right now is that let's pretend I'm calling the slow service, and I would like to have a timeout of 1 second. We know this operator already. It basically means that I don't want to wait more than 1 second for this system to reply. But what if we actually depend on this system in some way, and if it's too slow in this particular invocation, maybe we would like to retry. Maybe we would like to try another attempt, because maybe another attempt will be successful. So how can we apply a retry in RxJava? We just say retry, and that's it. And what happens here is, if the timeout operator succeeded, so there was no timeout, the retry operator is a no-op. It doesn't do anything. However, if the timeout operator emitted an exception, a timeout exception, this exception is going to be caught by retry, which can have the maximum number of attempts as well. This exception is going to be caught by retry, and it's going to be try to resubscribe, and maybe the next time very slow service will actually succeed. It will never succeed because we have a fixed delay here. Nevertheless, that's how you do it. Okay, so here's a bit of logic, and well, it looks cool, but what if we want to test it? How do you actually attempt testing such a logic? How would you test that you actually have a retry with timeouts? And by the way, this retry can actually have a very sophisticated version called retry when, which allows you to have a complex logic, like the first retry is immediately, then after a second, after 2, after 4, and if you have a particular exception, then don't retry at all. All of this can be implemented, but how would you test it? Because you don't really want to use tools like Awaitility. Maybe some of you know it. Awaitility is like a utility for testing code with timeouts or with any like blocking logic. You can say await for something in your unit test. You can put a sleep in your test and just verify it, but this makes your tests really, really, really slow, which is not the best thing to do. I'm out of time, so let's make it really, really fast. So what I can do, and this is like the most awesome part about RxJava, is that it actually has a test scheduler. A test scheduler allows you to take full control over time. So what happens is that every operator that in some sense relies on time, for example, timeout, can optionally have a scheduler, like here. And what happens right now, I can actually subscribe to it. What happens right now is that I have full control over how the time passes by. So for example, I can say test advanced time by 4,999 milliseconds. And as you can see, we have 4 retries. Advanced time by milliseconds, so I need to pass a unit here. I have 4 retries, which means my SOAP service is going to be invoked at most 5 times. The first invocation and 4 retries, so at most 5 attempts. So having this scheduler, I can actually synthetically advance my time by almost 5 seconds. Then I can run some assertions that there is no No result yet. We don't have time to show you the assertions, but there's a really cool support for that as well. Then I can take my scheduler and I can advance the time by 1 millisecond. All right, and now we got the exception. Or I can actually say on the very end, on error, return, and here's my error, and I can return, for example, big decimal 0. All right, so this is another declarative operation. So if an exception appears within a stream, I can just like replace it with a fixed value. Of course, this means that I'm going to swallow the exception, so I can do one error and do some logging, right? But this is just yet another operator that you can use. All right, but the thing is that because you have total control over how the time passes by, you can run very fast, very predictable unit tests with the actual time. So we can actually put assertions here, and don't be afraid that if GC comes in, garbage collection comes in, or maybe you have a slow server or whatever, you're actually gonna get a test failures that you didn't anticipate. Okay, I think that's all we have. If you have some questions, just come back to me, step by to me, and yeah, it was a pleasure. Thank you very much.